Now recording, and so I wanted to talk a little bit about the correlation coefficient, and then I will also have a video tomorrow about the t-test for the exercise 3. So basically the correlation coefficient is a stronger assessment tool for when we want to assess causality. And it's really a necessary step for understanding whether a variable contributes, whether a causal variable contributes to a response variable. A few properties to note about the Pearson's correlation coefficient. One is it always ranges between -1 and +1. Positive scores or positive values reflect a direct correlation. That means that as the causal variable increases, the response variable also increases. Negative scores indicate an inverse correlation, and this is to say that when the causal variable increases, the response variable decreases. Conversely, when the causal variable decreases, the response variable increases. A score of 0 indicates absolutely no correlative relationship at all, and so that would be there would be an assessment that there's not a causal relationship there. A perfect score of 1 or -1 indicates a perfect or exactly proportional relationship. So if your causal variable is 2 and your response variable is 4, and then your causal variable goes to 6, which is 3 times its original variable, we would expect to see a response variable value of 12. Now, if it's too linear, that may in and of itself not be very exciting as far as healthcare and social science are concerned. So you often would see something like if your causal variable went from 2 to 6 and your response variable went from 4 to 11 in one case, and then if you're in another state where the causal variable goes from 2 to 5 and the response variable goes from 6 to, or let's say from 7 to 13, then both of those are demonstrating a direct relationship, but it's not perfectly linear. And that's really what we're doing to capture that. Now, how do we calculate what is the mathematical definition? You don't need to be terribly concerned about this because you can use the Excel core function, which I'll get to in another brief video. But basically, the R stands for Pearson's correlation coefficient, and it is a case where you want to sum all of the x values minus the mean of x in your sample and multiply them by the response variable values minus the mean of the response variable. You take that sum and you divide it by the divisor, which is the sum of the x values minus x bar, or x, the mean of x squared, times the individual y values minus the average of y also squared, and that will give you the relationship there. At the bottom here, I've given you some guidelines for assessing relationships. A Pearson's correlation between 0, and by the way, these are symmetrical. So I'm in this case using direct relationships, but for inverse relationships, it's the same basic parameter values or Pearson's estimated values, except they're negative numbers instead of positive numbers. And so Pearson's from 0 to 0.1 indicates no relationship. Some people would say a Pearson's as high as 0.15 indicates no relationship. I would leave that to your judgment. Generally, as samples grow larger, you need a lower and lower Pearson's indicates a stronger relationship. If there's an association between 0.1 and 0.3, if Pearson's is between 0.1 and 0.3, then we would say that there's a weak association between the cause and response variables. An association between 0.3 and 0.5, R is greater than 0.3 but less than or equal to 0.5, that's a moderate association between the two variables. When we get to R is greater than 0.5 to 0.7, that's a strong association at that point. And anything over 0.7 I consider to be a very strong relationship. And so that's, in a nutshell, what we have for this today, and I will be continuing with the series of other videos shortly. Sorry. let me just see if I can now stop this. I seem to have lost my command.